Good morning, guys. All right, so today we are going to try tackling word problems. And you guys can totally do this. This is absolutely manageable. I have total confidence that this is going to be amazing. So I'm going to give you some strategies on how to get through this. So here is the first problem on your worksheet. This is where we're going to start. And this is kind of a crazy example, so it's a pretty good place to start. And one of the main things I need you guys to know is that we're not going to use grid paper. We're going to use math to do everything. So all of your drawings, we're just going to kind of freehand sketch and get all of our numbers by using math. So there's going to be a bunch of times when I'm going to have this pause the video and have you guys work out some math on your own with the people around you. So here's where we're going to start. So with this problem, this is a pretty typical example. The only thing that's going to be different is that all of these numbers are going to turn out kind of nice, and that would definitely not happen in real life. So what we're going to start with here is this example here. And so this talks about how people planning, like city planning, trying to decide how to plant different trees. So they give us a ton of information, and they're trying to decide how many spruce trees to plant and how many maple trees to plant. And there's lots of information here, and it's all mixed up. So all in here, there's tons of different stuff, and you guys can see it's all kind of mixed up in different orders. And one thing that's kind of stressful about this is that it's not all organized in one specific spot. So the constraints aren't all together, the variables aren't all together, and the objective function is somewhere separate. So the first thing we need to do is sort out what's going on. And so the first thing we need to do is to decide what are my two variables. And you can always pick whatever letters you want. You can assign them however you want, but it's always going to be best to, if you're going to compare and talk to each other, I would talk to your neighbors first and decide, hey, what are you going to do for X? What are you going to do for Y? And I always use X and Y so I can graph them on a normal coordinate plane. You could certainly pick different letters, but I think it's easiest to just stick with what we're comfortable with. So I'm going to go ahead and I'm going to notice that the two different things that we're talking about here are spruce trees and maple trees. And if you ever can't decide what are my variables, you can give a fake answer to the question. The question says, how many of each tree should the city plant? So if I gave a fake answer, my fake answer might be 15 spruce trees and 10 maple trees. Well, I just told you what the two variables are, spruce trees and maple trees, because in my fake answer, that's what it would look like. So I'm going to go ahead and list out here, and I'm going to say that I want spruce trees to be X and maple trees to be Y. You could have picked separate, but it's definitely a good idea to agree with people around you so that when you're comparing your equations and your answers, you can kind of be on the same page. So that's the first thing that I would write down if I was you. I would decide on my variables. So I'm going to go, whoa, group those together. That's so convenient. All right, I guess they're just going to stick together. All right, so the next thing that we're going to do is we need to pull out our constraints. And so we need to figure out what those constraints are going to be. So I'm going to actually go to a new slide. I'm going to go ahead here, and I'm going to add my new picture. Alrighty. All right, so we're going to put this back on here. And we're going to go ahead and talk about our constraints. And so the constraints are the things that limit us. And so the first thing that it says that limits us is we've got money. It says they have so much money to spend, and then they also have so much land available. So we want to go ahead and write constraints both for money and for land. So we're going to go ahead and do that. So the first one is going to be for money. And so the one for money, so we're going to pick out all the information we can about money. So I see, first of all, that spruce trees give me a fact for money and maple trees give me a fact for money. So I'm going to go ahead and write that out. So spruce trees are 30 bucks. So that tells me I'm going to start with 30x. Maple trees are 40 bucks that it says right here. So I'm going to go ahead and list that as 40y. And then they tell me that that has to be, they only have $2,100. So that means that this total right here has to be less than or equal to $2,100. So that is my first constraint, and that's the one that deals with money. the next one is space. That is the other thing that limits what I can do. And so I'm going to go ahead and write one that has to do with space. So space is, they tell me spruce trees require 600 feet of space, and maple trees require 900 feet of space. And that the total space is 4,500 square feet, so this is going to have to be less than or equal to 45,000. Oh, I said 100, it's 1,000. So that's my constraint for space. So that gives me these two constraints. Now, we also want to talk real world. Those are the only two things that limit what I can do. Now, if you're looking at this and you're like, well, what about these things down here? It says spruce trees absorb this, maple trees absorb this. That's not a limiting factor. That's going to come up later with our objective function. That's like what you guys did on your homework last night. Okay, that doesn't limit what I can do. That's what I'm going to try to be maximizing later. That's our key word here that tells me that's part of my objective function. So that's not a constraint. I'm not using that yet. I'm saving it for later. All right. And I'm guessing a lot of you guys right now are underlining stuff or highlighting stuff or marking it off, and that's exactly what you should be doing. So that's where I'm at right now. So here's where we're at. Here's my constraints. I'm also going to have something like spruce trees. They have to exist. I can't have negative ones, so those have to be greater than or equal to 0. Same with the maple trees. Okay, they have to be greater than or equal to 0. Sometimes they might tell me I have to have more than 10 spruce trees. If that was the case, I wouldn't need to include this right here. But since it's a real life thing and they didn't tell me anything like that, I have to include these. Okay, and basically what this is going to do is this is going to limit me to quadrant 1. All right, you guys can understand that. That's pretty basic. Okay, so here's where I'm at. That's what I need to include. Okay, so we're going to go ahead here, and now that we've got that, what I want you guys to do is we need to figure out now how to graph these two guys on my grid. So we're going to go ahead here. I'm going to go to a slide, and I want you guys to go ahead and draw me a little sketch. Now we're basically in quadrant 1, and these two lines right here give me my x is greater than 1 and my x is greater than 0 and my y is greater than or equal to 0. All right, that gives me my quadrant 1. Those lines are there. I know it's going to be everything over here and everything up here. So now I have to get my other two lines, and now you guys don't write these in here where I'm going to write them. I want you to write them off to the side, but we're going to treat them like equations. All right, we have our 30x plus 40y equals 2100, and my 600x plus 900y equals 45,000. What I want you guys to do right now is we're going to go ahead and pause those. And actually, you guys can go ahead and keep treating those like the inequalities, okay? And right here, you can keep doing these as our less than or equal to. I want you guys to go ahead and graph those. I want you to find where the intercepts are going to be. And so if you remember from a couple of days ago, I would set those up with my 0 blank and my blank 0 for each one. So you'll do that for the first one, and I'll give you a heads up and a warning. This guy here, you're going to get a decimal for this number. That's okay. That's cool. Don't let it freak you out. This one's going to be pretty. This one's just going to have a 0.5. All right? So I want you to go ahead and find your intercepts for this guy, graph it. Find your intercepts for this guy, graph it. Okay, you're going to have two lines. They're going to intersect. All right? And you're going to get a feasible region. So I'm going to have this pause the video right here, and then I'm going to have you guys talk about it and do that. And then when you're ready, we'll go ahead and move on. Now that you guys have done that, hopefully you have some kind of a sketch that looks kind of like, this is going to be real rough because I have this real sketchy iPad and I'm drawing with my fingers, so just be kind of nice to me here. My drawing sucks. Hopefully your drawing is a little bit better, but we're using math, so it's not a real big deal. So let me see. Actually, I'll draw it a little nicer. I know what it should look like. It should maybe look a little more like that. Yeah, that's real nice. You guys should be really happy and clap for me right now. All right, so probably what you guys saw is that this guy here, I'm not going to put the whole coordinate on here because I don't have space, but this was at 52.5, this was at 50, and this was at 70, and this was at 75. Hopefully you guys all agree with me. If you don't, I'm a little worried, okay? So what I want you guys to do now is we need to find the coordinates of this point right here. And the way we're going to do that is we're going to find the solution of this system that we had written on the last slide. So that's going to be the system with the 30x plus 40y equals 2100, and my 600x plus 900y equals 45,000. So what this is going to be, guys, is this is going to be a real nasty system that we're going to solve with elimination. So what we're going to do is we're going to go ahead and pause the video again in just a second, and I'm going to have you guys go through and solve this with elimination. You guys can do this however you like, but I would probably try to get the x's to match. I think that's going to be your best bet. So I'm going to have you guys work together. We're going to pause the video right now, and we're going to find this solution. All right, so now that you guys have done that, hopefully you guys found that the coordinates of this point right here are 30, 30. All right, so what we have now is we've got this feasible region, and I know I tell you guys not to do your sketches like this, but I don't have a highlighter here that can fill this in. So this is my feasible region, all right? So this guy right here is 0, 50. This guy is 30, 30, and then this guy right here is 70, 0. And this one here is 0, 0. So we've got 1, 2, 3, 4 vertices. This guy doesn't matter, this guy doesn't matter, they're not part of my feasible region. All right, so now that I've got these, I can go ahead and try and figure out how to maximize my objective function, which we haven't even written yet. So now that we've got all of that, I'm going to go ahead and make a new slide here. And I'm going to go ahead and bring this back up so that you guys can see this. And plug this in. So now that we've got this, you guys can see we haven't done anything yet with all this business. So we've got 650 pounds per year of carbon dioxide for spruce trees and 300 per year for maple trees. So what that tells me is that my objective function is going to look like this. P equals 650x plus 300y. And after last night's homework, you guys should be feeling pretty good about this. And you guys should be able to make your little table that looks like this. Yay, so beautiful. All right, now I think I put these in kind of a wonky order, okay, but you guys can see this, and you guys can copy down this table. This is what this is going to look like. So right now, you guys can copy this down. I'm going to have the sub pause the video so you guys can fill in the table, talk to each other, and compare your answers. And then we're going to start it back up, and we're going to talk about what that means in real life. Okay, so pause it for a second. We'll jump back in. Alrighty, so hopefully you guys got some answers that looked like this. Now, if we look at this, what we were trying to do is we were trying to maximize carbon dioxide absorption. So out of all these numbers, this one is the biggest. All right, so this guy right here, this line is my winner, but remember, this is not the number that I want to put down for my answer. This is what I'm looking for right here. And if you guys remember, X referred to spruce trees and Y referred to maple trees. So my final answer is going to be that I should plant 70 spruce trees and 0 maple trees. And that is what I'm looking for. All right, and that's how I'm going to give my answer. If someone said, well, how much carbon dioxide are they going to give out? That's this number, but that's not what we were going for. We were going for how many should I plant, and that is this answer right here. All right, so that's how we're going to go through and do this first one. I will give you guys a heads up that number 2 is a little bit different because some of the variables are going to have their own constraints. All right, number 3 is very similar to number 2, and then number 4 is very similar to number 1. You guys can work together. You can do this. I believe in you. Good luck. Nice job.